Guys, Nathan Duck River Honey. I'm here with Greg Burns of Nature's Image Farm and Cory Stevens and Dr. David Peck. So this is a group I'm very excited to talk to, all of them. Dr. David Peck worked with Thomas Seeley for his PhD, so he's very familiar with the Arnott forest bees that are in Honeybee Democracy and the lives of bees and all this. And
Awesome.
Viewers of my channel will recognize Cory Stevens. Of course, he's a VSH, Varroa sensitive, hygienic, mite-resistant queen breeder. And then, Greg, you're from Ohio.
That's right.
And how many colonies do you run?
We run about 300 colonies. We raise between 1,000 and 2,000 queens and nukes at a much smaller scale than a lot of folks that you'll see here. So I'm really excited to hear what these guys have to say and learn a little bit more about what they're doing for the betterment of the queen bee and the bees in general.
Yeah, awesome. So obviously mite resistance is the topic of this one. Dr. David Peck, explain, either one of you, explain how honeybees have become or can become resistant to mites, because there are some that are useful to the beekeeper and there are some that are really not that useful to the beekeeper. Mm-hmm. So what are some ways that bees can survive mites?
So there are really a cluster of traits that we've been able to identify. And the important thing to remember when we talk about bee biology or a bee breeding program or anything that we as beekeepers do is we only know as much as we figured out so far. The bees probably know a lot more than we do. So there are a number of traits that we've given names to over time as we've been trying to understand what happens when you put mites and bees together and some of those mites wind up getting killed by those bees or failing to reproduce or whatever trait it is you're looking for. So you've got hygienic behavior, which at its heart is a worker bee identifying that there's something wrong in a brood cell, uncapping that cell, and then typically another bee coming in and removing whatever problem is going on. So often that winds up manifesting as the entire pupa or larva being removed. Mm-hmm. But if there's a Varroa mite in there, her reproduction is interrupted. She might very well be killed in the process. Mm-hmm. But you have other traits. Of course, you have grooming, which means that you've simply got a bee who has a mite on her, who instead of scratching and failing to kick her off, or scratching and maybe kicking her off and she jumps onto another bee, maybe she scratches her off, grabs her, and then bites her with her mandibles, rips off a few of the mite's legs, which is no good for her. So there's a series of different traits. You know, you can talk about reduced development time. If you've got a bee who's going to be capped for less time when she's in that cell, that means that the Varroa mite is in there sort of just desperately squeaking out one or maybe two daughters in a worker or a drone respectively. Suddenly, if we compress that time period, we've got a mite that can't reproduce in that colony because there's simply not enough capped time for them to exploit. So each of these traits are traits that we've been able to identify, and especially things like the hygienic trait, we started with a very basic understanding of it. Mm-hmm. And as we've continued our breeding programs, the research programs that have gone into it, we've understood that some of what we thought was going on wasn't quite what was going mm-hmm. on. Sometimes we thought two things were happening when it was really one thing, and sometimes we thought it was one thing when it was really two things. So it's really every new study that comes out, every new person who gains expertise, you get new insights into how it works. Mm-hmm. You have anything to add to that?
No, that's exactly right. And, you know, I've kind of focused more so on the VSH or SMR side of things, but what you said absolutely applies. Right. You know, and kind of one thing I'm looking forward to seeing coming out more is, and I think there's overlap, like between Kaira Wagoner's UBO, I don't know if you're familiar with that, unhealthy brood odor. Yep. So they're noticing something's wrong mm-hmm. and identifying that, you know, through olfactory methods. Right. But just the more we pull that, the more we find out too. Right. And, you know, with general hygiene, freeze-killed brood, you know, Rothenbuehler figured that out a long time ago. And we keep finding out more things. Mm-hmm. But like Kaira said, there's a difference between knowing that there's a dead pupae in there versus, you know, the odor or pheromones they give off if they're stressed or something's not quite right. So it's awesome to see that go farther too. Mm-hmm. And I've seen lately, you know, there's kind of some debate over SMR now. It's almost mm-hmm. like somebody, because I feel like John Harbaugh mm-hmm. Articulated that and then changed it to VSH. Right. But I still feel like he kind of owns that, and that's more of a direct uncapping the pupa, throwing it out. But then we have some like low Varroa growth. Guelph is talking about that,
right?
And
but is that the same trait and just a different breeding program, or is it a different trait that they're selecting for?
Like you said, the more studies and the more
the VSH and the SMR is such an interesting one because the nomenclature of that gets people all caught up. Right, so the VSH is Varroa-sensitive hygiene.
Right.
You take a hygienic bee who just rips out brood, and then we look for whether or not it's Varroa-sensitive by doing tests like putting Varroa mites into cells and then seeing if they get taken out.
Right.
You got the SMR, which wasn't really necessarily about what the bees were doing. It was about what you observed. You'd open up cells and find that the mites were non-reproductive.
Right.
So we knew that there were non-reproductive mites there. So at first they thought maybe the bees were secreting something that was interrupting mite reproduction,
like a brood effect.
Exactly. And that's still entirely possible. There's some evidence that there could be some of that going on in some resistant populations.
Let me interject. Let me interject for just a second. Have you guys explained what SMR is yet?
Sort of.
We use lots of acronyms.
Right.
David, suppressed mite reproduction.
Right.
And it started as opening up capped brood, finding that a lot of the mites that you found in there hadn't reproduced, and thinking that something was suppressing the reproduction. Came to find out what was really happening, at least for the most part, is that when the mites did reproduce, they were getting hygienically removed.
Right.
So that's why it got turned into this VSH story. And so the mites that were left were the ones that hadn't reproduced for whatever reason. So it wasn't so much the pupa interrupting those mites, it's that all the other mites who had tried to succeed wound up getting ripped out. So we give these things names, we give them acronyms. It's sometimes hard to follow, even for folks like us.
Right.
And then it turns out that we were wrong about the acronym, we were wrong about the name, so then we have to change it. So the worst thing is, as a scientist, you sit down, you try to read up the scientific papers. If I want to look for something about VSH behavior, well, I've got to look for SMR behavior for a certain number of years because some labs were only using that language. So it's, unfortunately, a lot of science moves at science's pace. It moves at however fast it moves.
True.
And in beekeeping, especially with Varroa, the mites arrived and we had to solve the problems immediately. And this is, when I talk about Varroa reproduction or Varroa resistance, when I also talk about, any of the Varroa management techniques, the pesticides, things like that, we as beekeepers, as an industry, as a community, as hobbyists, whatever we consider ourselves, have had to jump in and solve our Varroa problem first and then go back and say, well, what does the science tell us that is? Or what does the law tell us we were supposed to have done in the first place? And so it's an awful lot of juggling we have to do just because the Varroa mites and the biology of the situation is moving so fast, but sometimes our understanding does not keep up.
Right, absolutely. And to tie that in, too, I think a lot of people, like you said, we had a problem. We had an industry that was in jeopardy and we're crashing. So we needed quick, short-term solutions. Otherwise, we're done. So, and like you said, we have to kind of go back and figure things out. Well, now that we've got a better perspective, we've got some better miticides too. Hopefully more will come out. But from an entomologist perspective, the cornerstone or the holy grail of an IPM program is host resistance.
Right.
So if we don't have host resistance, the only tool in the toolbox we have are the best, miticides that we're aware of. So I think you could look at them as tools in a toolbox. We should use them all, but I think that in his, like he was articulating, we had to have a solution quick. Now that we know a lot of this stuff, I think continued emphasis to put on that and this to have a more, I don't know, I think of a wrestler. If your base is really solid, they're not going to throw you around. If we've got host resistance and we've got good miticides, and hopefully they keep coming up with better ones, that have less impact on the bees. We're more stable, and the industry is less at risk.
Yeah,
and it doesn't have to be 100% host resistance. And that's something people really struggle with, right?
Yeah.
They think that if you're breeding bees and you're saying, I find that I have to treat half as often, or I only have to treat once every year or two. People think, oh, well, you failed at your job.
Yeah,
you have not produced a mite-resistant bee.
Exactly.
But the reality is that just like anything else, it's a tool in the toolkit, right?
Exactly.
A wrestler is not all base, right? You got to have some other skills. And in the same way, to really effectively manage mites, some people will call me a an optimist because I think that we're going to increase mite resistance over time.
Oh, yeah,
Some
I
people
agree.
call me a pessimist because I don't think we're ever going to get a mite-proof bee.
Yep, exactly.
So
yep.
you do the best breeding program you can. We study what we can about these survivor populations, figure
Right.
out what they're doing, and then harvest those traits when we can use
Absolutely.
them. But then
Absolutely.
recognize that, like, we still have to be investing in new synthetic pesticides and
Totally.
new organic acid pesticide methods. All of that's going to fit into it. We've got to learn more about swarming and splitting and using that to manage the mite populations. Because if we can cycle all of those things, you know, over the course of our year, if we can link it all together, as you say, it becomes a bunch of different steps, a bunch of different tools. They get the job 50% of the way done.
Yes,
And if
exactly.
you use a few of those at once, all of a sudden it becomes an easy, almost trivial problem.
Right. And we don't want to put all our eggs in one basket either.
Right.
So Nathan was talking about, you've studied the R-knot forest bees. You know, I'm sure they've got a different mechanism. They swarm a bit. You know, they keep
Yep.
a smaller brood nest. They'll shut down brood rearing at times. And you have VSH. And I think some people want to go all in on one, or this
Right.
one's the best. We
Right.
only need to do that. No.
Right.
We need to know more and more and more,
Yeah,
and
our-
probably not put all our eggs in one basket
Our
either.
current understanding of the R-knot forest bees, and those who have read Tom's book, particularly Lives of Bees, explains it pretty well. I think it explains it better than my dissertation does, but a lot of the work in there sort of came out of my research.
Oh, awesome.
But essentially, you're right. It's that Tom's research has shown us that bees that live in small colonies, bees that swarm frequently, bees that are widely spread, are bees that are going to have an easier time of dealing with Varroa. It doesn't solve it, but it makes it a lot easier. It might be a problem and not a catastrophe.
Right. Yep.
A lot of my research was looking for Varroa-sensitive hygiene, looking at hygienic behavior, looking at grooming behavior, looking at uncapping, recapping behavior,
Oh, yeah.
which is something we haven't
That's
even talked
awesome.
about.
Yeah.
But it's similar, we think, to that UBO.
Yeah.
It's that
Yeah.
you get the uncappers that go and open the cell, but then instead of ripping the pupa out, the mite gets confused. Maybe the male mite wanders out and gets crushed somewhere,
Yeah.
and then they just get capped over, and the pupae keep developing.
Yes.
So all of those different traits, what we found looking at the R-knot bees, same thing, that shortened development time. We found not a lot of it, but a hint of it in those survivor bees. So if you are a survivor bee, why put all your eggs in one basket?
Right.
It's not about investing in the perfect silver bullet that solves the problem 100%.
It's
about
dangerous.
saying, I'm going to swarm, I'm going to be small, I'm going to be Varroa sensitive hygienic, but I'm also going to be a better groomer. And if you daisy chain all of that together, you wind up with a really good system to fight
Absolutely.
Varroa mites. And that's, I think, what we're finding is that at first everyone wanted a mite resistant bee. They looked around and said we don't have any, and so we moved on immediately.
Yep.
And we jumped into we need the best pesticides, and that's been the road that most people have been following. And I really appreciate the work of folks like you.
Sure.
Even there are, you've got treatment-free beekeepers who just don't want to think about Varroa mites.
Yeah.
Yeah.
But you've also got treatment-free beekeepers who are trying to understand what their bees are and aren't capable of surviving.
Right.
Maybe their treatment minimal, right? They might try not to treat as much as some people because they're more interested in seeing whether they've got a more survivor bee or less likely to survive bee. But we need to have these conversations now that we've sort
absolutely.
of stabilized a little bit. Yeah, we've got the miticide. Sure, we can all survive. We're not going to, not have anything to pollinate the almonds next year. But how can we improve so that our lives become easier and our bees do better?
Absolutely.
I'd like to add a little bit of context here. Obviously, if anybody is new to beekeeping, Varroa mites do not belong in Apis mellifera, the western honeybee. They came from Apis cerana, the eastern honeybee, and were accidentally introduced, and they have it's a huge, huge problem. Western honeybees don't know how to deal with it. And, there is a treatment-free movement, and I really look at it as almost like two species of honeybees. You've got honeybees living in trees in the R-knot forest, and they're going to be okay. People say, are honeybees going to be able to survive Varroa long term as a species? Yes, they're going to survive, and they're going to be okay. And then there are honeybees that live in boxes that are loved by me and everyone in this building. And, it's a different species because I don't just want them to survive. I want honey from them, and I want wax from them. I want splits
productive
from them. I
livestock.
want nukes
Right.
from them. I want them to be economically viable. So it's a completely different thing. And some of those traits that allow bees to survive Varroa Smaller
swarming
bee,
annually, or
swarming
twice a year.
frequently, frequent
Not ideal if you wanna make
absconding, and
honey.
Sure.
all these sorts of things are very, very undesirable traits if you're trying to be economically viable with them. So, I think that's an important context to add to the discussion. Is there's just a big difference in those two things.
There are.
There seems to be this weird little misunderstood or hard to understand area outside. Everyone appreciates all the work that you guys do on dialing in the things that you guys just spoke about. There seems to be situations where we can also be washing zeros and ones, but be very clearly seeing something going on with viral loads and disease inside of a colony outside of some of the basic things that are going on. While you mentioned short-term and long-term strategies, right, to get to where we're trying to go, there also seems to be something that I think a lot of us don't fully understand, myself included. While you're working towards those things that you guys just mentioned, where does viral resistance come into this conversation at play? What to look for? How does this actually fit into this whole long-term strategy?
One thing I've noticed, whenever I first started messing with VSH stock, I would buy Tom Glenn breeders. Well, being the curious person that I am, I would find a colony that had a high degree of displayed parasitic mite syndrome or withered wings. So I would switch that queen out with a VSH queen, which was USDA bred at the time from Tom Glenn. Within 6 weeks or so, I noticed that the parasitic mite syndrome was gone.
Wow.
And that was repetitive. This wasn't just a one-off thing.
Right.
And so this ties into Kaira's research as well. Where that overlap is, I don't know. But that's why I got hung on VSH, because I felt like it was multifaceted trait. So, you're not seeing chalk brood. You're not seeing American foul brood, I guess, with the hygienic function of it.
Right.
It's more than just Varroa-infested cells. It's unhealthy brood.
Right.
So you have that. You have the viral resistance. And to me, that's why I focused on that one so much, is because it has such a heavy viral resistance. And Kaira's UBO assay is showing the same stuff, so there's overlap with VSH.
Right.
How much I don't know. More to come.
It's important it's important that we use the right nomenclature here, because what you're saying right there is that we're talking about the UBO assay. The assay is not the trait.
Correct.
The assay is the test.
Correct.
So we've got this spray that we can, spray down onto these colonies, and I've assisted with some of that research, and it's being expanded into Vermont. So I got to see some of it in action, right? You sit there with your spray bottle, you spray this unhealthy brood odor, simulation essentially on the caps. Bees come in and they uncap it. That's a test. The test is, if I spray this stuff on here, what do my bees do next? That doesn't tell me what their traits are with regard to Varroa.
Right.
VSH is in many ways the same thing. Now, you've got different methods. There have historically been different methods to evaluate VSH.
I'll use a Harbo assay.
There you go. So the
you're
Harbo assay
measuring.
is one of other
Exactly.
assays.
Yep.
But whatever assay you use, it's entirely possible that you'll have a high UBO score, a high Harbo assay score, and it'll be because it's the exact same trait that you're measuring.
Right.
So it can get very difficult to navigate all of this stuff. Again,
totally.
just to be able to talk about it clearly, it requires a sort of a whole textbook or a whole definitions page.
Absolutely.
So I've got.
That's why I was hung up on that so much, just because it was. I saw it as multifaceted. But Purdue was working on allogrooming traits as well, and I don't want to. I mean, I love VSH, and I'm kind of focused on studying and breeding for that, but I don't want to encourage people not to look at other ways either, because it may be like a combination of things, that we could breed into a bee that would make them even more to where you don't
want to win a trophy for having the most VSH bee on the planet Earth, right?
Exactly.
If you had bees that
John
were
Harbo
performing
has
well,
that currently.
and then it's too much. But if you had a bee that was performing really well for you, you might say, "Geez, I'm doing these Harbo assays. I'm making my selection. I'm bored of this. It's at 100% in my population. I can't or don't want to get any better." You might then say, "Well, why don't I do some grooming tests and see if of my stock that I've been able to cultivate to this point, maybe I can get the ones that groom better too."
Absolutely.
Right? It's all about stacking those different traits together, because that's how nature does it.
Right, exactly. And I'd gone down that rabbit trail already. Whenever I did some Purdue, I back-crossed them with VSH semen. And the problem is there's always trade-offs, and I did get allogrooming and VSH in the same trait, but I got some wicked aggression in some of them.
Yeah.
And I didn't have enough time to properly parse through it. And you would really want to test for both and then find the ones that are and go that route.
Yep.
I didn't. I kind of scrapped it and moved on, but surely some smart young kid will come along and do the same thing. But if you have, concentrated sources where you know to get it from too, and that's another thing, is if just one guy is breeding for VSH and everybody's buying it, that's a giant genetic bottleneck. That's not good, which is why I like to do podcasts and things of this nature to say, well, here's what I know, here's what I did,
Somebody else help
here's
me.
what
Somebody
I
else
don't
do
know.
something.
Exactly. and train people to do that themselves, because, if Nathan starts selecting in his neck of the woods, then we're not bottlenecking so much. If I mess around and get too high level, too much inbreeding, then there's other people that are doing it as well because they've heard the education and started the process, and then you can outcross and get right back to where you need to be.
And the great fun of that, of course, too, is that if you've got high VSHBs, you breed some high VSHBs, and then you decide you're going to do some back crosses, then you get to find out if it was VSH that got there with the same genes or VSH that got there with different genes.
Exactly.
You might have two different flavors of VSH, and now you can get a double or a half as much or different versions of it.
Absolutely.
So more selection, more careful note-taking, more selection on our bees, regardless of the trait, gives you and everybody like you more opportunity to say, well, I like what you're doing. I have this. I wonder what would happen if.
Yep.
We
and
don't
then
know
create
novel,
novel crosses because,
maybe something will work better.
Yep,
maybe
exactly.
we will get a mite-proof bee. It'd be fun.
Yep.
Corey, I've got
possibility.
a quick question for you. So, VSH is beneficial to honeybees, right?
I would say so.
Beneficial trait set. Why is it recessive and not dominant?
Well, you might know a bit more about that. And it's not just one trait, though. It's a trait set. So,
and it's going to be a population of genes that all have to be in the right alignment to lead to the behavior that you're looking for.
So the only way for it to become dominant is basically for Varroa to become so virulent that it kills all the other genes off.
If you want to run a selection experiment, the best way to do it is to introduce a whole lot of death. Because the more animals that die, if they don't have that one trait you're selecting for, the fewer animals will be left that don't have it. And if you can kill everybody except the ones that are VSH, then those genes are probably going to show up in the population a whole lot more a couple generations down the line.
Are we going to get to a genetic cliff at some point?
It depends on what we do.
Where we lose diversity in honeybees?
We don't have to, no. We can do that in ignorance, but if you have a bit of education, no, I don't think it's an issue at all.
And the important thing, of course, is that because honeybees, by their very nature, the way that they reproduce, you've got a single queen who is in this colony who is mated with maybe 10, 20 drones.
Exactly.
There's a huge amount of genetic diversity coming in, and they even have genetic mechanisms that help prevent inbreeding that also sort of add diversity to that population over time. So a population of bees, especially since primarily what you're doing is you're selecting VSH matrilines, you have control over your drone sources, you're mixing and matching within there.
Yes.
But you get new drones coming in sometimes, and that's actually valuable. It's interesting.
Exactly.
It makes sure that things don't go a little funny.
Right. Yeah, and where were we going with that? Inbreeding? Well, that's why I was talking about if we teach people to be able to do that themselves, and they have their own little unique populations that are genetically unique in different parts of the country and probably perform better in those areas of the country. As soon as Corey is not paying attention or makes missteps and has inbreeding, all I've got to do is contact, hey, David, could you send
Can you help me out? I just want to bring some new blood in here.
Right, and then you have, not only do you have, you're getting rid of your inbreeding because you're outcrossing, but then you have
whatever I did.
Right.
Whatever I produced.
Well, then we have heterosis too, like hybrid vigor coming in, and you've got just, your bees are ready to rock and roll again. They're a bit more vigorous. So we could make a problem. But honestly, as far as the diversity goes, as long as we keep managing our bees and keep our hands off, they sort out with the open mating and multiple matings.
Yeah.
That's
it's a queen breeding. Inbreeding is a queen breeder's problem or an
Exactly.
instrumental inseminator's problem. As soon
right.
as I get a queen from you and I just put her in my yard, there's plenty of drones around. There's going to be new genes mixed in. Now, I might wash out what you're doing. The hope is that maybe it washes out over the course of a few generations and doesn't happen all at once immediately.
Right, exactly. Lose it.
since that's the typical use case for most of these bees, whatever you're producing, you're boosting those VSH genes in the overall US bee population for every queen you
increasing
sell.
the frequency of expression, basically.
But you've still got plenty of open mating coming from those drones, so you're not. I don't think we've got much to worry about.
I don't either. And that's the thing, whenever people say VSH, I love it that he mentions we need to talk about this more and we need to discuss, and because a lot of people think it's one thing and someone thinks it's another, and then you have, I think they kind of thought Harbo left the SMR, maybe, and so we're going to apply that to brood effect and stuff. So I think these conversations are crucial to have to educate us on what we're doing, what it is we're working with, and where we probably need to go.
On this specifically, you say words have different meanings to different people. My mind works a little differently than most, but you say host resistance is the end goal.
That's a blanket term. Yeah.
Well, when you say host resistance, I automatically start thinking about, well, it's not really host resistance, it's host-parasite symbiosis, where they live together and the parasite doesn't overwhelm the host. So has anybody approached it from that perspective? Like, how do we tame these mites down to remove the most virulent lines?
Yep. So a part of my doctoral work was actually looking at mite transmission between colonies. And a big part of that, if you ask an evolutionary biologist or a disease ecologist how you wind up with a disease that is less likely to kill, its hosts, and you very rightly pointed out, Varroa's only been in this species of honeybee for maybe 100 years.
Exactly.
That is not a lot of time for any of these changes
a lot of evolution
to happen. But if you ask a biologist what you need, the answer is you need to have very little transmission from, if I get you sick and then I'm killing you, but I can jump into me and then jump into her and then jump into him and jump into everybody else, then there's a great opportunity for me to just benefit no matter how sick I keep making everybody. But if it's hard for me to spread into some unrelated, bee colony next door, then that's what's going to select for the Varroa mites that might be less likely to cause death. So that was a big part of why I was doing a lot of that research, was trying to understand that. But another point I'll just make, when we talk about host resistance, we really have to bring in the word tolerance as well. So in biology, when we talk about host resistance, if you're talking about host resistance of honeybees to Varroa, that means the Varroa population stays the same or goes down over time. They are resisting those mites in their reproductive efforts by eliminating the mite population. Tolerance is I can go out to a colony, open it up, and I've got 80 mites per 300 bees or something ridiculous like that, and the bees are still doing okay. That's tolerance to the Varroa as opposed to resistance. The complexity, though, of course, is exactly what you talked about, right? If we've got these viruses in here, maybe what I'm looking at is the Varroa haven't been causing much harm in the first place, and I just got a low virus hive, and I think it's tolerant.
Yeah.
So, it's a little... I feel bad for people who try to interview me, because it must be frustrating that every time you try to ask me a simple answer or a simple question,
there
I
are
give you
no
free answers
simple,
and say it's complicated. I don't even understand it.
It depends. It depends. Yeah.
Well, that's really interesting. Like, a big problem is, and I don't want to say negative things about commercial beekeepers, but people complain a lot about bees coming back from almonds loaded with mites, and then they have dead outs, and my hive went and robbed out these hives, brought back these extremely virulent strains of mites, and my whole yard is dead now. What is it going to take? And I think it's going to take concerted, consistent management practices by beekeepers, which will never happen.
No, we can't even agree if a screen or a solid bottom board.
The work that Cory's doing is the solution to that, right? Cory is the perfect supporter for a lazy beekeeper or a commercial beekeeper who just doesn't have time to keep their mites really well under control.
Way to go, Cory.
Because the bees are going to do that work for them, right? And like every single thing we do, how much honey could you make if I took all your bees away? Not a lot.
Exactly.
I could give you a pipetter and you could go out and get some clover flowers and start boiling it up on your stove, but you're not going to make much. The bees are the ones that do the work, and we only benefit when we work with them in whatever they're up to. This is the same thing. Yeah, I can get a miticide. Yeah, I can swarm them and split them and do all these different things to try to suppress the mite population, but I need to get the bees to do some of that work for me, because they're always better at every job I ask them to do.
Right. And that's why I brought in natural selection, too, because a lot of the work that yielded what Tom was studying was all natural selection. Well, why I took the approach that I did is if we utilize natural selection, which has been here as long as we've been around, for sure, and then tie in, well, we specifically want to select for this. So work with nature, not against nature, add our technology to it and be good stewards, then what comes out the other end is mutually beneficial.
Right.
Well, there's one
in theory.
One more thing I'd like to talk about.
If I did my job.
But it's a little more complicated than that.
Exactly. Yes. Totally.
We're not going to treat ourselves out of this problem. And I treat my bees for mites, but they are going to become resistant to more and more things over time. So you're always looking for that next silver bullet. What do you is this going to get easier over time or harder? I mean, what's the path forward look like?
The first desperate attempts at getting an effective treatment had some downsides, right? We were using Apistan, we were using Coumaphos, the taufluvalinate and the Coumaphos were both things that built up residuals in the colonies. They led pretty quickly to resistance because those residuals selected from resistant mites. What we are now seeing, the reports of the Amitraz resistance, it actually seems a little more promising. The mechanism is different, and the work by Frank Rinkovich is showing us that if you go in and you hit an Amitraz-resistant mite population with oxalic acid for a little while, suddenly you can treat them with Amitraz and it'll kill them again. So it's not quite as dire as it has been, but you're absolutely right, that if we keep putting the same pressure over and over again on those mites, they have a very strong evolutionary pressure to figure out a solution. We don't know what it'll be, but they might figure it out.
Right.
Will we produce a mite that's resistant to formic and oxalic acid because they can tolerate being acidified? I don't know. Probably not. The mechanism makes it much less likely, but I'd never rule it out.
Yeah.
So that silver bullet mindset has got to go. The idea that Cory has chosen the silver bullet of traits, or that breeding mite-resistant bees is a silver bullet, or that Amitraz or that oxalic acid or the silver bullet is a fool's errand, and it confuses people. It gets them thinking, I just didn't use the right thing, and not saying, I don't understand all of the many options available to me, and I didn't mix them together in the right way. I think that's where we're going.
I agree, and we'll keep moving forward too, because as David said, we think we know something, and then there'll be a couple studies, and we kind of knew, but now we know more. Well, that's going to continue. So I think the more that we know, we'll come up with innovative solutions and change, or we might find another highly effective trait set. We know of several right now, but and
if we did, we wouldn't abandon VSH.
Right.
We'd see if we could get both of those at once.
Yeah, utilize them both. Absolutely.
Right.
Cory, 20 years from now, what are Varroa mites going to look like in beekeeping?
20 years from now?
Yeah.
That depends on what we do. That's a big if.
Oh, come on now. I want hard predictions.
If we went all in and really funded research and pushed people to produce stock that has proven host resistance, the people that are producing chemical acaricides may not like it very much because the market would shrink. To what degree, I don't know. But no, it's, if you go to a bee meeting, and this is changing rapidly because of conversations like this, but, I would go to my local bee club and say, has anybody heard of hygiene? One or two hands. VSH, maybe. Now, I'm trying to chatter about it there, so that's changed since then. But overall, I don't think that the industry has accepted it. Though whenever people start saying Amitraz resistant, now
everybody's pounding on your door and saying, hey, can I get some of them bees?
Exactly, they're all ears. So I think that the industry as a whole is shifting to be more open to that and know that we don't need to put all our eggs in the chemical basket. We need to utilize that, be more educated on it, and look for other options, but that's not all we need to be doing. And I think people know that now. So I'm going to be optimistic like David.
Dr. Peck, same question. 20 years from now, what do you think will be different?
Well, let's go back 20, 30 years or so, and let's talk about Isle of Wight disease, which swept in, killed huge numbers of bees. Beekeepers were put out of business. They gave up beekeeping. Families that had been keeping for years just couldn't keep their bees alive. And what we called Isle of Wight disease, we now know was tracheal mites.
Exactly.
So the tracheal mites so effectively killed the bees that were susceptible that we wound up with a whole bunch of tracheal mite resistant bees. It didn't hurt that when Varroa showed up, we started using all these miticides, and so I'm sure that was a nail in the coffin for the tracheal mite.
Yeah.
But if we find ourselves in a position where we wind up with an amitraz-resistant mite and an oxalic acid-resistant mite, I don't think that's going to happen. But if it did,
agreed.
if they were resistant to everything we had, what would wind up happening? Well, a lot of bees would die, but there'd probably be some left, and then Cory and I would grab them and start breeding them and figuring out what they were doing.
Exactly. What's going on in here?
Exactly. So I think that you've got a potential to select the easy, horrible way, which is that you just let a whole lot of bees die.
Yeah.
Or you can put in the work. You can do what Cory's doing. And, I'm now the Director of Research and Education at Better Bee, now that I've moved on from Cornell. And at Better Bee, we have our own queen breeding program, breeding northern queens, and we're doing the same thing. That's where I got involved in some of the new UBO testing up there.
Oh, cool, yeah.
We're incorporating more of these traits, and we have this same mindset. Now, you're focused on a trait, and you're playing with some other stuff.
Right,
We're
exactly.
trying to juggle all those traits at once and see what that produces. And it might be a worse bee than yours. It might be a better one. We'll find out.
I would say there's definite potential there, especially if you're paying attention to what goes in. And as I know you are, and finding out what level's right or what combination is right and what works out.
But I think you're going to produce different bees. I'm going to produce different bees. Hopefully they'll be better than what we've got. And the goal for the beekeeper that doesn't want to watch that nightmare scenario where we watch 80% of the colonies in the U.S. die is... don't be cheap about it, right? We're an awful cheap industry or an awful cheap hobby, however you think of yourself. But
true.
You can't just say, well, I already got queens. I'm not going to pay him for queens. I can get these queens for $15 and those queens for $16.
They
I'm
look
not paying
the
that
same.
much. Right? They both lay eggs, don't they?
Right.
So if we accept that over time, the alternative to letting all of our bees die is a stock replacement where we start getting some of these good traits at high levels and start mixing those into what we're managing, I think that's probably going to be... I don't think we're going to be without Varroa mites in 20 years, but I think we're going to turn the volume down on how frustrating they are for us, and it's going to become something that we just manage, like we manage, tracheal mites or European foul brood or anything else that might pop up. It's something you deal with, but it's not going to be the catastrophe that some folks still have.
More of a nuisance.
Yeah, exactly. Yeah.
Mm-hmm. Cory, when I was interviewing you, we were talking about treatment-free and basically, you said, and I can't quote you, I don't want to put words in your mouth, but you basically said that people need to know whether they're part of the solution or part of the problem.
Certainly, yeah.
And specifically, I think about this, with this channel, I try to encourage people to get into beekeeping. I strongly believe we need more beekeepers, and it is such a steep learning curve, and it's so hard to be successful, but if you can get past that first year or two... you can be a 20-year beekeeper pretty easily. It gets so much easier. But how do we get people into beekeeping and also say, but guys, don't, here are the warning signs that your hive's about to collapse from Varroa and you need to do something about this. How do we connect those two so that we can achieve some of these things where we don't get these mite bombs that are more virulent? And I think a lot about all this stuff.
I think you've hit the nail on the head, is that when folks get into beekeeping, it's not because they want to manage a bunch of parasites, right? Folks get into beekeeping because they like honey, and the bees cooperate, and they're cute and fuzzy, and they got stung one time, and they want to be brave and get over their fear. Like, there's a lot of reasons to get into it, and managing Varroa mites is not one of them. So as a new beekeeper, because there's so much that you have to learn, it's pretty easy for folks to say, well, I'll just ignore this disease management part of it. And I think that as mentors, as advisors, whether it's a one-on-one relationship, whether it's a YouTube channel, whether you're selling products, you've got to make sure that you emphasize to people, welcome to this process. I want you to succeed. I want you to have good luck with these bees. And a part of that starts with, you've got to understand Varroa mites. When I teach Better Bees beginner classes, it's a 6-hour-long course, and I talk about all sorts of things that can go right and that can go wrong, but I spend a good long chunk of it talking just about Varroa, and I say, A if B exists, E if B exists, bears might eat your hive, skunks. I can answer any question you've got about them, but I promise you that the only questions that you're going to need the answers to before you get started or in your first year is the basics of how to manage these mites.
Yep, that is true. Yeah, and I was going to say just a one-word answer, too, is just education, which that is exactly it, and just letting people know. And now, instead of reading a book that somebody wrote on the East Coast and finding it somewhere, we have the internet, we have podcasts, got top-shelf speakers that you can hear speak about it firsthand and give pointers, and so, education.